Alcohol. Bond angles in alcohols. All the HCH and CCO are 109.5 degrees, and shape is tetrahedral because there are four bonding pair of electrons repelling to position of minimum repulsion. HOC bond has bond angle of 104.5 because there's two bonded pairs of electrons and two lone pair repelling to a position of minimum repulsion. Lone pairs repel more than bonded pairs, so bond angle is reduced. Boiling points. Alcohols have low volatility and high boiling points because they can form hydrogen bonds between alcohol molecules. Smaller alcohols dissolve in water because they form hydrogen bonds to water molecules. Different types of alcohols. Primary alcohols are alcohols where one carbon is attached to carbon joint to oxygen. Secondary alcohols are alcohols where two carbons are attached to carbon joint to the oxygen. Tertiary alcohols are alcohols where three carbons are attached to the carbon joint to the oxygen. Oxidation reaction of alcohols. Potassium dichromate is oxidizing agent that oxidizes alcohols. The reaction is based on type of alcohol, like whether it's primary, secondary, or tertiary, and the conditions. Partial oxidation of primary alcohols. Primary alcohol to aldehyde using potassium dichromate and dilute sulfuric acid. Warm gently and distill out aldehyde as it forms. Aldehyde's name ends in al. It always has C double bond O on first carbon of chain, so it doesn't need a number in its name. Observation is orange dichromate ion reduces to green. Primary alcohol and O forms aldehyde and water. Write oxidation equations in simplified form using O in square bracket. Writing formulae of aldehydes in condensed way, write CHO not COH because COH is an alcohol. Distillation separates organic product from reacting mixture. Maximize yield collected only collect distillate at approximate boiling point of desired aldehyde and not higher. Bulb of thermometer at T-junction connecting to condenser to measure correct boiling point. Water in bottom against gravity and allows more efficient cooling and prevent backflow of water. Electric heater used to heat organic chemicals because organic chemicals are highly flammable and set on fire with naked flame. Full oxidation of primary alcohols. Primary alcohols oxidized to carboxylic acid. Use potassium dichromate and dilute sulfuric acid. Use excess of dichromate and heat under reflux, and then distill product after reaction has finished. Potassium dichromate ion reduces from orange to green. Reflux. Heat organic reaction mixture for long time and condenser stops organic vapor from escaping by condensing them back to liquid. Don't seal the end of the condenser because gas pressure can build up, making the apparatus explode. Anti-bumping granules are added to flask in distillation and reflux to stop vigorous, uneven boiling by making small bubbles form instead of large bubbles. Don't draw lines between flask and condenser. Don't have top of condenser sealed. Condenser has outer tube for water that's sealed at top and bottom. Condensers have two opening for water in and out that are open. Oxidation of secondary alcohols. Secondary alcohol to ketone. Potassium dichromate and dilute sulfuric acid. Heat under reflux. Orange to green color change when it's reduced. No more oxidation of ketone under these conditions. Tertiary alcohols can't be oxidized at all by potassium dichromate because there is no hydrogen atom bonded to carbon with OH group. Distinguishing between aldehydes and ketones. Tollin's reagent formed by mixing aqueous ammonia and silver nitrate. Active substance is complex ion of silver and ammonia. Heat gently, and aldehydes only are oxidized by Tollin's reagent into carboxylic acid, and silver ions are reduced to silver atoms. Aldehydes form silver mirror form coating inside of test tube. Ketone don't have color change. Felling solution, which is copper ions. Heat gently aldehyde oxidized by Felling solution into carboxylic acid and copper ions are reduced to copper oxide. Blue copper ions change to red precipitate. Carboxylic acid tested by addition of sodium carbonate, and if it fizzes and makes carbon dioxide, then carboxylic acid's present. Reaction of alcohol with dehydrating agents. Alcohol to alkene using concentrated sulfuric or phosphoric acid. It must be warm, and the acids are catalysts, and does an acid-catalyzed elimination. Dehydration reaction is removal of water molecule from molecule. Some secondary and tertiary alcohols can give more than one product when double bond forms between different carbon atoms. Example, butane 2. OL can form alkenes, but 2 ene would be formed. But 2 ene could also exist as E and Z isomers. Producing alkenes from alcohols gives possible route to polymers without using monomers from oil. Forming ethanol. 1. Fermentation. Glucose to ethanol and carbon dioxide. For this you will need yeast, no air, and temperature. Optimum temperature for fermentation is like 38 degrees Celsius. Lower temperature means reaction is smaller, and higher temperature the yeast dies and enzymes denature. Fermentation done with no air, because presence of air can cause extra reactions to happen. Oxidize ethanol produced to ethanoic acid. Advantages are sugar is renewable resources and production uses low-level technology and cheap equipment. Disadvantages are batch process, which is slow and give high production costs, and ethanol made is not pure and needs purifying by fractional distillation and depletes land used for growing food crops. 2. From ethene. Ethene from cracking of fractions from distilled crude oil. Ethene and water forms ethanol, and this is a hydration reaction. Hydration is addition of water to molecule. Conditions are high temperature, pressure, and catalyst, like concentrated phosphoric acid. Advantages is faster reaction, pure product, and continuous process, so cheaper. Disadvantages are high technology equipment needed. Ethene is non-renewable resources and high energy cost for pumping to make high pressure. Ethanol as biofuel. Biofuel is fuel made from plants. Carbon neutral means there's no net annual carbon emissions to atmosphere. Ethanol made from fermentation is a biofuel. Ethanol made from this said to be carbon neutral because any carbon dioxide given off when biofuel is burnt would have been extracted from air by photosynthesis when plant grew. So, no net carbon dioxide emission into atmosphere. Photosynthesis removes 6 carbon dioxide molecules from atmosphere when plants grow to make 1 molecule of glucose. Production of carbon dioxide by fermentation and combustion. When 1 molecule of glucose is fermented, 2 molecules of carbon dioxide is emitted. 2 ethanol molecules made will then make 4 molecules of carbon dioxide when they are combusted. Overall form every 6 molecules of carbon dioxide absorbed. 6 molecules of carbon dioxide are emitted, so no net contribution of carbon dioxide to atmosphere. This doesn't take into account any energy needed to irrigate plants, fractionally distill ethanol from reaction mixture or process fuel. If energy for these processes comes from fossil fuels, then ethanol made is not carbon neutral.